G'day, it's Mark here at Combi Life, and I want to welcome Ruben Muller. Ruben, great to see you here
Thank you for
at Combi Life, and thank you for your support over the last year and a half as we've sought to develop a really outstanding, best-in-class solution for enhancing the power capacity of the Volkswagen Transporter T5, T6, T6.1 short or long wheelbase with single seats or single plus a double bench seat, and for California Multivan Transporter Caravelle and so on. Ruben, where do we start? The battery.
Yes, so we developed a battery together that's a 160 amp hour lithium battery. This is lithium iron phosphate. It's not the dangerous lithium that you might have heard of. This is a very safe battery. Not only is it safer than other types of lithium batteries, but it's also safer than AGM batteries.
So lithium NMC, lithium, sometimes lithium ion, or AGM batteries, they can off gas and cause those sorts of issues. If they're overcharged, they become volatile.
Yep.
That's not the case here, is it, with lithium?
No, it's not. So we've tested these overcharging, under discharging, a puncture test. And while you do have some electrolyte leaking when you do that, you do not have any fire, anything like that. And with the electrolyte, I think it's also worth mentioning that inside this battery is a contained area. So if there was ever an electrolyte leak, which wouldn't happen, we've never had one happen, you could then vent it to the outside as well.
Okay, so it's double cased effectively. So
Yes.
we've got a case that we slide this battery in with the case, but then within that case there's another case containing all of the cells.
Yes, correct.
And talking about that testing, we've done that testing. We haven't done that in the backyard, have we? We've done that in laboratory conditions.
Yes.
To certain standards. Can you talk about the laboratory and the standards?
So we've got a bunch of certifications. So we have UN 38.3. We have the IEC certification, which is becoming a bigger and bigger talking point. It is optional, but it's definitely good to have. And then for the European markets, we also have the CE certification,
which we often see on many of our appliances. We see those CE marks. Even on some of our Volkswagen equipment we see that. So that's good to know that we have all those certifications, like those drop tests, puncture tests, piercing tests, overcharging tests, vibration tests, and so on.
Yep.
So this is not like a battery for my solar on the side of my house that sits stationary in controlled conditions. This is a moving object that goes on smooth roads, rough roads, hot conditions, cold conditions, and we're in good stead there. Now we've got that out of the way. Let's talk about some of the features. So I asked you to try and exceed our original capacity the best we could ever fit here was 125 amp hours.
Yep.
Which in the old money AGM was sort of over 200 amp hours in the old AGM lead acid type days. So it's still a lot, but I asked you to do as much as possible. Where did we land?
Yeah, we ended up with 160 amp hours. So if you opened up this battery, it would be completely full with the prismatic cells that are in there, as well as the BMS. So yeah, as you were referring back to AGM capacity, so this is probably at least equivalent to 250 amp hours, possibly even 300 amp hours of AGM capacity.
In the old rule of thumb of 300, or say, or a 100 amp hour battery, we could discharge at 50%.
Yep.
Use about 50 of those 100 amps.
Yes.
Well, with a 300, with that 50% idea, we're sort of down to almost 150. Mm-hmm. So here we've got 100, 160. So it's
here you actually can use the entire 160 amp hour.
That's right. That's right. So that's taking us down to about 10 volts, isn't it?
Yes, it is.
You mentioned an acronym earlier that we haven't yet explained, the BMS.
Yes.
Something we talk about all the time, but the BMS is really rather important in this scenario.
It is. It's the battery management system, and it protects the cells effectively. So it makes sure they're not overcharged, under discharged, too hot, too cold, all these sorts of things.
So if we press on our screen here, which helps represent what's going on with the BMS, there's a bit of information here, and then some further information on those other screens, isn't there, that helps us see those cells?
Exactly. So this is all coming from the BMS, or battery management system. It's telling us that the state of charge is 86%. We're discharging with just under 2 amps.
Yep, we've got some lights on and so on in here. Yep.
We've got 13.3 volts total voltage, and it is 22 degrees. So at the current level, we've got about 80 hours worth of storage left.
Yep.
But then, yeah, you can jump into the other screens as well. It'll tell you how many cycles you've done. One nifty feature here is also you can turn off the discharge.
Hello, our lights have gone off.
I have just turned off all the lights. So this is basically when you're connecting or disconnecting something and you want to make sure that you don't accidentally short anything out. You just turn off the discharge, and then if you touch positive and negative together accidentally, nothing will happen.
That's fantastic. You can also turn on and off the charging functions as well.
You could.
Not so critical really in daily use.
That's not as much of a safety feature as the discharge.
Yeah. You mentioned the total voltage. That's because it's made up of some smaller voltages, isn't it? So
correct.
We can see that on the next screen.
So there's 4 individual cells in here, and each one of them is about 3.2 volts. You can see it's more than 50% charged, so it's 3.3 volts. And you can also see that the voltages are quite close together.
Which is what we want to see, really.
Yes.
We're really good to see that. We don't want to be discharging one set of cells and not the other.
Correct.
So it's evenly discharging and evenly charging. And yeah, 3, 4, 12, so, but we've got 3.3, so we're just over that 13, 13 volts, which is really, really healthy. And you know, our fridges are designed in our system to draw about 3.3 amps at 12 volts. Mm-hmm. But if we've got a higher voltage, we can draw less amps.
Correct.
So that's really efficient then, rather than having my old AGM battery sitting maybe pretty fast at 11.8 or 11.7, mm-hmm. I'm actually drawing more than that, sort of 3.3 amps.
Yeah, so with fridges, which is a great example because most people that have vans like this would like to have a fridge. We've seen fridges last roughly 5 days, sometimes a little bit more. It depends on the color of the van, what temperature.
Outside temperature.
Ambient temperature, as well as temperature in the fridge.
How much is in the fridge? Are you parked in the sun or the shade? Exactly. Hot day, cold day? Is the fridge full or not full? And so on and so forth.
It's worth mentioning that the 5 days is without any charging. So on this battery, we have 2 ways of charging it. So we have, under the seat here, we've got a Red Arc Core 40 DC-DC, which can charge off the alternator with 40 amps. In this van, we'll get to it a little bit later, but we also have a solar panel on the roof. Nice. So effectively, with those 2 combined, you would never run out of
We're indefinitely off the grid.
Yep.
So no solar panel, totally cloudy. I mean, we could have a portable blanket and plug it into our solar port here with the regulator or non-regulated port there. Yep. But even if I had no solar whatsoever, I've been camping for some days, I could, if you go back to the main screen, Ruben, I could start the vehicle and we should see relatively swiftly.
Yeah, once the DC-DC kicks in,
we should see it's gone from discharging to standby and now it's on charging. What rate are you seeing, Ruben?
It's 41 amps. So this being 160 amp hours, if we charge with 40 amps, that means we'd get a full charge in about 4 hours of driving. Yes. Now, it's important to note that you don't have to do the 4 hours of driving in one go. You can do it over a few days and you'll still have battery capacity left.
We've had these on the market now for some time. I have not really heard of many people even below 50% or even 70, 80% might be pretty common. The vans are very, very agile. We tend to be restless and nomadic people. So we've been here a day or two. Let's go up the road, up to the cafe, to the lookout, to the next beach, over to the range, to the bushwalk, whatever. And we've done 20 minutes there, 20 minutes back. We've quickly added in that 40 minutes, something like 25 amps back into the battery, which is more than enough generally for the next night.
Yes.
So that was 86% a few moments ago. Now it's 87%. I'll turn the engine off. We can see how that's replenishing.
And then we've got a couple of other connectors. You mentioned the Anderson connectors here, both of which can be used for charging with solar, or even if you have an AC connector, you can use the grey one.
Yes.
But you can also, of course, use this grey one for discharging.
It's bi-directional. We can charge or discharge.
There's also a few more of those under the seat. So these lights, for example, would be connected to the one.
I don't have to have an unsightly wire running down my B pillar and into the front of the battery. So there's accessibility to the battery concealed under the seat, as well as for more convenient access at the front, but we've also got some more traditional ports on the front as well.
Yes, absolutely. So the more traditional one, like you mentioned, what everyone knows is the 6-socket, 15 amp one. A lot of cars only come with 10 amps. So
Or even 5.
some even with 5. So you will be able to run all your 6-socket appliances off this.
Yes, 15 amps is considerable. It's going to be
Yes.
quite warm.
Yes.
What else?
The other one we have on here is a 65-watt USB-C and 18-watt USB-A charger, which you can turn on here. So 65 watts is quite a bit. You can charge your laptop directly off this with a USB-C to USB-C cable. A lot of USB-C charged laptops come with a 65-watt power brick. So this would charge at the same rate
As the power brick.
Yeah.
And we're going to get to the inverter shortly, but it means I don't have to go from 12 volts to
Exactly.
240 volts on the inverter, which has then some parasitic losses and so on.
Yes.
To then go back to the 12 volts and 65
Yep.
watts on that power brick.
Yep.
I can just plug it in directly. So my MacBook Pro has that sort of system. I just USB-C,
Absolutely.
put that straight in.
So
I'm
this-
charging the laptop really
This is
fast.
power delivery, so it will put out, I believe, anywhere up to 22 volts. It'll negotiate with the laptop or phone or whatever you plug
iPad,
into.
whatever the tablet.
Yep, and it'll find the right voltage and then connect to that and give you the maximum current available.
We've sold quite a few smallish inverters, 350 sort of watt, 500 watt inverters, so people can charge their laptops and iPads. That's not really the case anymore. We can do an inverter, but for other purposes, not for just charging the
absolutely.
laptop. So that's really, really good. Now, we've got all the power at the front here. The great reason to have it here is it's a rather dead space in the van. I'm not really using it. The vans are not an entirely large footprint, not some big Winnebago bus or something like that. So we've used a dead space. We make space within there for all the fuses and factory wiring. Nothing gets disturbed in that way. But I actually need the power down the back.
Yes.
So I've got my cabinetry in my van. I might have cabinets where I'm sitting now in a traditional camper van layout, or I might have the Van Essa systems where I'm at the back of the van cooking outside. So let's have a look. How do we get the power from here down to there, Ruben?
Yeah, great question. So you can't see it, but we've got a power cable running along the bottom here.
Single cable?
Yes, so single cable. So we've just got the positive and we've got a ground return basically through the chassis.
And so down the back here, we've got it mounted in the wall. If you have cabinetry in your vehicle that's going up the side of the vehicle, this could be in that cabinetry, and it could be on the left side, or it could be on the right side. So the kit comes with enough cabling for left or right, long or short.
Long, yep.
Great, that's great. So tell us about this panel.
Yeah, so it's somewhat of a duplication of what we have on the battery. So again, you've got the touch screen.
Optional
that you had with the battery. So if you're cooking back here, for example, you might want to know how much is left in the battery.
Because we're going to talk about things like induction cooking and so on, and that's maybe where I'd be really interested to see what's happening there.
Then we've got two regular Anderson connectors. They connect directly to the battery. So again, you can use these for discharging, but you could also use it for charging.
So if I had that solar blanket with the regulator, the 200 watt solar blanket I've got out the back here because the sun's behind me because I'm watching the sunset as we cook, I could actually have that solar blanket plug in here, charging that battery up the front.
Yes, you could.
Great.
And we are actually charging with solar into this red Anderson here. What we've got here is we've got a 50 amp MPPT, a Victron MPPT. We mentioned that you can use some unregulated solar blankets and so forth with the yellow port on the battery.
Which uses the Red Arc's own MPPT.
Correct.
Which has some limitations associated
Yes, it's
with it.
limited to 32 volts, whereas this one is a 150, meaning the input voltage can go up to 100 volts. So the solar panel we've got on the roof here.
That's a lot of volts.
That's a lot of volts.
From the sun, from
a lot
my
of volts
sunshine.
and a lot of current.
That's from the sun.
Yes.
Which is Australia's very sunny.
Yeah, it's
That's
a great
lot of
place
current.
for solar.
Wow, that's a lot.
So we've got a 430 watt solar panel on the top of the roof, on the pop-up roof. So whether you have a solid roof or a pop-up roof, you can install a 430 watt panel. 430 watt is a lot of power. So basically, we were talking about 4 hours on the alternator.
From 0 to full?
From 0 to 100, yep. This would take 4.5, 5 hours, something like that. And obviously, if you can do a combination of both as well.
Unlike with the Red Arc, I've got the MPPT control in the Red Arc, but if I have my engine running and solar running, it splits it.
Yeah.
The maximum output of the Red Arc is the 40.
Correct.
So I have to split. If I'm getting 10 amps from my 200 watt solar panel,
Yep.
then I'm only getting 30 from the engine if that was running at the same time. But in this case, I could run the engine, run that, and that would be putting in perhaps 35 from here.
To 80. Or,
Yep, but say
Combined.
35 and then 40 from there, 75 amps, maybe even 80. That's, wow, that's really, really fast. But really, if you do have the rooftop solar arrangement, we're not running the engine, we're off grid. So even on cloudy days,
You'll still
even in
get
winter,
some,
we're seeing some reasonable current coming through, often coming through because it's hour by hour by hour by hour by hour the current's coming through. I can't discharge my battery fast enough. it's catching up all the time. So unless I'm running, which we're going to see shortly, kettles and toasters and induction cookers, or electric blankets all the time, we're really going to be ahead of the curve at all times. So we have seen a few customers coming through with really serious battery setups inside their cabinets down there. So they've got 200 or 300 amps of lithium. But really in this case, with the 160 plus this solar, we can be off grid, I would say, indefinitely. And I don't need to waste more space on my floor with more batteries.
Yeah, you basically just need enough battery capacity from sundown to sun up the next morning.
Yes.
You don't need enough capacity to last you a whole week or however long you're camping for.
Exactly right. Exactly right. So we deviated slightly on the solar, but just back here, we've got a few more ports here. So
So we've got another 15 amp 6 socket here. And we also have the same 65 amp USB-C and 65 watt USB-C and 18 watt USB-A as we did at the front. So if you have your bed set up, depending on what sort of bed you have in here, and you've got a laptop down here, you can also charge it from there.
yes, or in our pack bags, which are still inside this vehicle. We've taken the kitchen out to make it a little bit easier to see everything. But, I could have my phone in there charging overnight. So it's not, or I could have this van does not have fans, but on the back of this we also have ports. So again, we could mount our fan here and have power coming from the back.
Yeah, absolutely.
Okay, so we've got all this power in the van. What are we going to do with it, actually? So it opens up some new possibilities.
Yes.
We've mentioned on a previous video the advent of maybe hot water coming into the van, so a hot shower back here, that's good. That can run off 12 volts. But the big ticket item really is the inverter.
Yes.
So we're going to spin around and go back to the front and take a look at the inverter. As most people know, there's 2 seat boxes in almost all the Volkswagen vans, except that which has of this size, except that which has the bench seat.
Yep.
But here we have an inverter that mimics the footprint of the other. Now, we've seen even some big motorhome type of vehicles coming out with 1500 watt inverters. And the problem I have with that, it forces you to have to think.
Yes.
So what's 1500 watts? This kettle here, can I run that on 1500
That's probably
watts?
1800.
You see,
would
so
be
now
my
I've got to
guess.
think. So I couldn't actually run that on that motorhome's 1500 watt inverter. So tell me, Ruben, a bit about the specification of this inverter.
So this is a 2500 watt inverter, which means that you can run any residential appliance on this.
Can you go into that a little bit? 25, any resi appliance?
Yes. So a normal plug, like you have on your kettle there, that's a 10 amp plug. So multiply that by 240 means the maximum power a residential, appliance can use is 2400 watts. We've got 2500 watts. And
so we're in the clear.
yes, and we've got an inrush current that we've tested of up to 5500.
Inrush current meaning, sort of as I get this machine moving, whatever it may be, it could be my coffee machine, it could be my power tools, could be my domestic welder, TIG welder or something. There could be that big inrush current as it gets moving. There's maybe 4000 watts flying through the system. Even our residential systems allow us to cope with that brief inrush current, but it's got to settle at under 2500 watts.
Yeah, correct. And we when we got it up that high, we also tested it with 2 appliances at the same time.
Yes, we had to really sort of push it to achieve that. Okay, so this plugs in underneath. Now, there's no visible cabling here, Ruben.
No.
So I'm not got a trip hazard or some sort of hazard going on here. What's going on here? How are we getting from there to there?
The great thing is that the VW vans have a channel underneath the seats connecting them together.
Yes.
So we've utilized that to feed power from the battery through the channel to the inverter.
And that's quite a thick cable because there's a lot of power required
is.
here to do the 2500 watts maximum. So that's quite a thick cable, and
Yes.
that channel has capacity for that.
It does.
That's great. Well, let's turn it on. We'll hear a confirmation beep that everything's good, a green light. I have tried to stress this and max it out, and you end up with a red light, and the thing's got to cool down and have it's got a self-resetting fuse within the actual inverter itself. I think
It does. It does. And then we've got a DC fuse. We've got an RCBO for AC. So yeah, all the safety is taken into account for this as well.
Yeah, that's very, very good. So let's have a look here. This is a kettle. I've got a toaster. This is could be a common breakfast in Australia. So I could plug my toaster in here and engage that. So this will start doing something. And what are we seeing over there? Because we were talking about amps earlier.
Yeah.
So what are we seeing over there?
We're seeing around 73 amps. So it's also worth noting that the BMS is a 200 amp BMS, so we're well within the range. Even when we run the kettle in a second, we're still inside the range of the BMS.
All right, so that's my toast, so we'll give that the flick, and now we'll get the kettle going. I just put probably what's a couple of cups worth in there.
Sure.
So it's showing on here, just onto that, it's probably about 500 mils, so a couple of cups. Now this is making some noise now.
Yep.
Before the kettle makes noise. Why is it making noise?
It's just drawing a lot of power. So the noise is basically the fans inside the inverter spinning up, ensuring the inverter doesn't overheat, and everything stays nice and cool.
I sometimes get asked, is your inverter one of those fancy pure sine wave inverters?
Yes, it absolutely is.
And why is that important, Ruben?
It is important for a range of equipment that especially LED lights, they might flicker if it's not. I know we're running the LED lights of 12 volts, but there's a lot of equipment that does not like a very modified sine wave.
When I was in the IT industry, we always use pure sine wave for any sensitive equipment.
Yeah.
It can't be a square wave, it had to be the pure sine wave. So that was really rather important. Well, I can hear the fans going in the inverter. I can now hear my water starting to get warm. What are we seeing on the display?
We're at 170 amps.
170. Over here, I'm seeing 1,896 consistent watts. I dropped briefly to 1,770, but seeing 196, 1,896 watts, should I say there. So at 29 degrees, it says the inverter. That's a very comfortable temperature for the inverter.
Yes, definitely.
So that's excellent. So this kettle's given us about 500 or 600 millilitres, and that's hot to the touch. That's really hot. It sort of fascinates me, Ruben, that there's chemicals in that battery, and that's converted now to heat.
Yes, absolutely.
It's quite remarkable, really. Like what we as humans managed to invent. There's some chemicals sitting ready to use in the future, and now the future's arrived. I want to boil my kettle and my cup of tea, and it's got some hot water. It's quite remarkable.
One other thing worth mentioning is that there's also a outlet on the back of this inverter, and the reason that that's important is similar to you saying you don't necessarily want any trip hazards of things you permanently have plugged in. What you can have is a cable running down that side of the van.
Separating it from the 12?
Yes.
Because we've got the 12 on that side,
240 volts.
so have the 240 separated from the 12.
And then if you have a kitchen in the back here, you can have your induction cooker there as well.
Speaking of cooking, could I have a microwave?
You can.
Air fryer?
Anything you want.
Wow, that's pretty good. That's pretty good. Ruben, that's been really informative today. Thank you very much. Please don't forget to like the video if you've enjoyed this. Maybe subscribe for some updates. Click the little bell so you hear about new innovations that are coming. And maybe drop a few lines in the comments. We'd like to hear how you would use this system, or if you have any questions about it. But Ruben, this has been a big project. We've had many happy customers now. There's been a few refinements along the way, and it's just outstanding. So thank you for helping the combi community. We really, really appreciate it. Thank you very much, Ruben. Thanks for watching, and